Hi, and welcome back to my series on mathematical modeling of the coronavirus outbreak. In this video, we're not going to do any mathematics, but we are going to talk about how to measure some of these disease characteristics that we've talked about in previous videos, and you hear on the news and in the media the past few days. So how do we actually find out what the characteristics are of the disease? So we'll start with some questions that you've had asked yourself or heard in the news. How long after infection does a person become infective? Is the beginning of infections always asymptomatic, or can you go directly to symptomatic? Do asymptomatics always become symptomatic, or can you have the disease and recover and not ever be symptomatic, which seems to be the case? If not, if you don't, then how long are you infective as an asymptomatic, if you even are? Is the infectivity different between asymptomatics and symptomatics? Do I get a worse disease if I'm infected by a symptomatic person, or vice versa? Who knows? How long is a symptomatic patient naturally infective? After recovery, what is the nature of the antibodies developed? The concentration, longevity, the power of keeping you protected? Is it possible to lose your immunity? And if someone does lose the immunity, where does that person go back into the evolution of the disease? So we've heard a lot about testing. Is that the actual way to answer these questions? Are we going to get our information that we want simply by testing people? So here's a timeline, a depiction of the questions. First we have the timeline. And what we really want to know is a person is susceptible to the disease and then becomes infected, may or may not be asymptomatic. That infected symptomatic may go on to be an infective asymptomatic, so able to spread the disease. Then they might become an infective symptomatic, so you have symptoms and you do infect other people, and then you recover from the disease. And once you're recovered, can you relapse? Can you lose that immunity? So it's fairly well thought that people can pass from the susceptible classification directly to infective symptomatics. It's presumed, I think, that all the symptomatics are infective. Infected asymptomatics, people who are not capable of transmitting the disease and don't have any symptoms, can they actually become recovered, or do they have to go through other stages? If they do go into an infective stage where they can transmit the disease, do they have to go into the infective symptomatics? Do they have to develop symptoms, or can they just recover from the disease? What we think happens now is that the infectives asymptomatics do recover and don't necessarily become infective symptomatics. And then if you do have a relapse, where do you go? Do you go back into the infected asymptomatics who cannot spread the disease, or do you go back into asymptomatics who spread the disease, or can you actually become symptomatic again and infective at the same time? So those are the questions that we actually want to clarify by some kind of a study. So what we need to know is how is it that we're going to design a study to measure these things? Is testing the actual study design or not? So the first thing we do is look at what we call a cross-sectional study, or we can think of it as a snapshot. It's a study that's done in a short period of time. Short period could even be weeks or months, but the point in a snapshot study or a cross-sectional study is that generally the subjects are only measured one time during the study, and you get some kind of information about where they are in the evolution of the disease. So the age of the person, actually, when we look we can talk about several different concepts, at least two different concepts of age: chronological age or your disease age. So we actually want to know how people pass through the ages of the disease as well as the chronological age. When we have a snapshot study, and we cannot really deduce what's going to happen to those younger generation when they get older because the disease evolution does not go, it goes in time and not with respect to the age in your snapshot if you have simply a cross-sectional study. Those older generation individuals have lived a completely different life than the younger ones are going to live in the future. So another graphical depiction, I have some time t0 where I start my study and I observe data. And at that point, those younger people on the vertical axis, 16 years old, are not going to have the same experience and live through the same life as those people who are 60 years old at time 0. So what I really need to do, rather than think that my age progresses vertically like that, my age is going to progress throughout real time. And so I'm going to go and end my study at some point. So here's the point in time where we end the study. And what I'm going to know is about the evolution of those people, but I don't know what could possibly happen to those people beyond the end of my study. So what I really need to do is use my age more or less as a stratification to see what happens to younger people as they progress through time, what happens to middle-aged people as they progress through time, or older people as they progress through time. So I need a longitudinal study in order to know the answers to questions that are longitudinal. How long does something last? When does it stop? How does it change in time? You cannot really answer these questions, these longitudinal questions, with a cross-sectional study. You have to have a cohort of people. You have to get a representative sample, you would hope, of the people. This is where the sampling I've not talked about, but sampling becomes extremely important in this kind of study. So you start with a cohort of people who will be included in the study over a relatively short period of time, and you have to define what short is. Then those people must be followed up for a longer period of time. They must be measured several times throughout the study in order to take each of those individuals and see what their evolution is during the disease. So that's the point that I wanted to make today with this video. If you want to know answers to these questions, these very important questions that we asked here in our timeline, if you want to know the answers to all of these questions, you're going to have scientists who create a longitudinal study and follow individuals throughout the evolution of the disease. I hope you enjoyed this, and I'll see you in the next video. Bye.